Okay, we've been talking about adding and subtracting fractions. Now we're going to look at equations that have fractions in them, but we're going to perform the same steps. Let's look at this first example, but let's do it over here on our blackboard. Okay, as you can see, we have c plus 3/5 equals 3/4. Now we're going to perform the steps that we normally would if it was just a regular equation. So we're going to try to get c by itself. So look at what's being done to c. Well, 3/5 is being added. So the opposite of that is to subtract 3/5. So we're going to subtract 3/5 from both sides. Now, we've been adding and subtracting fractions, and you know we have to have a common denominator in order to add or subtract them. So I'm going to do that over here to the side. Now, common denominator between 4 and 5 would be 20 because they both go into 20. So let's change them to a denominator of 20. Well, to change 4 to a denominator of 20, I'd have to multiply it by 5. So I'm going to multiply the numerator by 5, and that'll make it 15/20. And on this fraction, I'd have to multiply 5 times 4. So I'm going to multiply the -3 times 4, and that'll give me -12. Do not forget to bring your signs over. So if we read the problem left to right, 3/5 minus 3/5 cancels out. That's what we wanted. So we're going to have c equals, and then 15/20 minus 12/20 is the answer, which is 3/20. So you perform the same steps that you normally would, but you just have to deal with the fractions. Okay, going back to our notes with the equations that involve fractions, I want to show you this last example. This one's from the book, number 75. We have p minus 1/8 equals 1/3. And to solve for p, we're going to have to get the p by itself. So instead of subtracting 1/8, we're going to add 1/8 to both sides, and that's what I did. Of course, to add 1/3 and 1/8, you would have to find a common denominator, which is 24. And so we changed 1/3 to 8/24 and 1/8 to 3/24, and that adds together to give you 11/24. So that's another good example of how you would get the variable by itself when you have fractions. Okay, now let's take a look at our notes in section 3.3 that involve the multiplication and division of fractions. But we're going to be looking at equations that have the multiplication and division of fractions. Okay, in example 1 here we have 2/3 x equals 62, but we're going to do this one together on the chalkboard. Okay, over here, we have to get x by itself. So what's being done to x is 2/3 being multiplied. So normally you would think, well, let's divide both sides by 2/3. So when we do that, let's see what we have. Well, you may not be sure what to do with that. So let's think about it. Remember, when we divide fractions, this is what we just learned, that's the same as multiplying by the reciprocal. So I'm going to write this problem a little differently. Instead of dividing by 2/3, I'm going to go ahead and multiply by the reciprocal of 2/3, which of course is 3/2, or 3/2. So I'm going to multiply both sides by 3/2, because remember, whatever you do to one side, you have to do the other. Now the reason why this is just going to give me x, because it's going to end up with 6/6, which is just 1x, or x. Or if you look at the simplifying here, you know, 3's will simplify and cancel out, and the 2's will simplify and cancel out. So either way, you'll be just left with 1x, and that's what we wanted. Equals, now let's do our multiplication over here. Again, we can simplify here because this 2 in the denominator will go up into the 62 31 times. And 31 times 3 gives us the answer, which is 93. And remember, anytime you want to check your answer, you can go back and put 93 in for x and multiply it times 2/3 and see if it equals 62. Now look at this other example. I wanted to try this from the notes. We have 20 equals -4/5 m. Now sometimes when students see the variable on the right side, it confuses them. So I'm just going to rewrite this. You can always do this. And I'm going to put -4/5 m on the left side, and then I'm going to put equals 20. Now from here, it's just like the problem before. We need to divide by -4/5 to get m by itself. Because -4/5 is being multiplied by m, we have to divide it. That's the only way to undo it. But dividing by -4/5 is really multiplying by the reciprocal, which is -5/4. So I'm going to multiply both sides by the reciprocal, which is -5/4. Now over here I have a negative times a negative, which will give me a positive, and then the 5's cancel out and the 4's, so I'm just left with positive 1m, or just m, and that's what I wanted. Now over here I have 20, which I can put over 1 times -5/4. That's going to be negative, well, we can simplify this because the 4 will go up into 20 5 times, and we'll have 5 times 5, which is -25. So that would be our answer, that one. Now in example 3, under the equations with fractions on section 3.3, we have 4x equals negative 3/5. Again, you might want to just divide by 4 because you think that 4 is being multiplied by x, so you need to divide by 4. Now that would cancel out, but it may be a little confusing over here. So let's approach a different way to do this one. We have 4x equals negative 3/5. Well, 4, which is the same as 4 over 1, instead of dividing by 4, we can multiply by the reciprocal, which would be 1 over 4. So if I multiply both sides by 1 over 4, that'll make it a little easier. 1/4 times 4 is just 1x, because you have 4 over 4, which is just x. And then over here, you'll just have negative 3 over 20, and that is the correct answer.